So welcome to Innovation and Crypto Ventures. And let me give you just like an overview of what this Coursera is about and why I think it's important for you to actually spend the time to go through this course. So this is a blockchain course. It's called Innovation and Crypto Ventures. And what I try to do is to give you the tools to navigate this incredibly complicated space. So historically, we've had many innovations that have led to a lot of prosperity and disruption. This particular innovation is different because it's so complicated. And when there's complication, people don't quite understand what's going on, and there's a lot of misleading information. We'll get people that try to sell you some blockchain-based product that really doesn't need blockchain. So part of this course is to bring you up to a level where you can identify opportunities that could be disrupted by blockchain. And also, you can easily identify the situations where somebody is trying to sell you some blockchain application that really is not what you want, and it probably won't work. So we're in this period where blockchain is popular, there's a lot of hype. People talk about cryptocurrencies and other applications. We need to navigate that. And we're in sharp need of navigation. This is a very significant disruption. And I'm going to take you through some technical details, which are important, but don't confuse this with a technical computer science course. Yes, we will talk about some computer science applications, but the heart of this course is about innovation, where this technology can actually have a big impact. So let me take you through the basic structure of the course. We will talk in general, I'll give you a broad overview of what blockchain actually is. We will talk about cryptocurrency, we'll talk about some computer science concepts, but then we're going to focus on applications. So the businesses that are prime for disruption. Come along for the ride. So my first goal is to give you a basic overview of what blockchain technology actually is. So in this segment, we're going to take a focused look at some of the key segments of this technology. So the first thing, and there's a lot of misperceptions about blockchain technology, and one of the major misperceptions is that the blockchain technology was invented in 2008 by Satoshi Nakamoto, the founder of Bitcoin. And that is false. So blockchain is something that was invented in a famous paper in 1991. It's been around for a long time. So one of the misperceptions is that blockchain is just about cryptocurrency. That is not the case. So again, this has been around for a long time. The second misperception is that blockchain is one thing, and it isn't. It's a technology. So let's kind of dive and take a look at what is the intuition behind this concept. And surprisingly, the basic idea is not that complicated. So let's start. And blockchain fundamentally is a database. So it's a database that's special. It's got some features that distinguish it from the regular database. And one distinguishing feature is that it's a distributed database. So let me show you a very famous figure. And indeed, I pulled this from a paper from the mid-1960s. And this paper was foundational for the internet. And the following problem was being addressed. If there was a Soviet missile attack on the US computing installations, which were centralized at the time, then all of the computers would be wiped out in the US. So research began to explore the idea of decentralized and distributed computing. And as you can see, the distributed computing, if there was an attack that took out part of the network, then the network would survive. And this is a foundational idea for the internet, and this is also foundational for blockchain. So blockchain database is one that is distributed. Now, it is true that there are other databases that are distributed. And most common is having like a backup location where you've got an identical mirror database. So blockchain is not just defined by having distributed data. There are a number of other features. Number one is transparency. So in a public blockchain, and we'll talk about public versus private, you can see everything. So anybody can download a copy of the database onto their computer, and everybody can see what's actually going on in the database. The third feature is unique to blockchain technology, and this is the idea of immutability. So a blockchain-based database, you can add to it, but you can't go back and edit. So most databases, you can go in and look at a historical entry and change it. With a blockchain-based database, no way. So the idea of immutability is fundamental. So if there's a mistake in the data, then that's just too bad. Maybe you can go add another transaction to correct the mistake, but the mistake lives on forever within this construct. So this is a very important property. The last property is fundamental, and this has to do with the cryptographic security of this particular database. So it's called blockchain because it's not one big sheet of data. It is broken into subsheets or blocks. So blockchain is a set of subsheets. And what about the chain idea? Well, the chain is an ingenious invention by Haber and Sternetta. So the idea at the end of a block, there is a signature or a digest of the information in that block. And that digest is sensitive to the information in the block. And then that digest or signature is repeated in the first line of the next block. So there's a linkage or a chain that takes all of these blocks and connects them in a linear way. Okay, so it's not like they're mixed up. Everything is sequential. And this is this idea of having something that's historically secured. Let me talk a bit about the different types of blockchains. So the classic blockchain is a public blockchain. And we'll talk in some detail about the Bitcoin blockchain because it's by far the most famous. So a public blockchain is a blockchain that is known as trustless. And what does that mean? So it means that there are many different people that have a copy of the database, and they're kind of verifying that the transactions are valid, which means if you're spending, then you need to have the money to spend. So it turns out that I don't need to know who these people are with copies of the database, and I don't need to trust them at all. Effectively, everybody is doing the same job. So this technology is redundant. So everybody is verifying transactions. So it's not a central person doing this or an institution. It is everybody. So you don't need to trust. However, that is something that's a benefit that is not free. So we'll talk about the mechanisms later in the course that allows you to do this distributed, effectively trusting the network rather than individuals within the network. So Bitcoin, as I mentioned, is a classic public blockchain. Ethereum is another technology that we will talk about. Ethereum allows for these smart contracts. This idea, you get into your car, you check the ownership, and if you're in default, the car doesn't start. That is a smart contract. Ethereum can do that. Bitcoin cannot. So already we're seeing there's many different applications and types of blockchains, and we need to navigate through that. So the security, the verification, there's many different ways to actually do this. So currently, Bitcoin and Ethereum for cryptocurrencies use something known as proof of work. And that is very computationally intensive. And indeed, some of these cryptocurrencies have been criticized because of the amount of energy that they actually use. It is fundamentally important that you understand that this is only a choice. So the founder of Bitcoin made that choice. The founder of Ethereum made that choice. Indeed, Ethereum is already on record that they will move to a different mechanism called proof of stake. And again, we'll go into the details of what this means, but essentially proof of stake is a voting mechanism where the people that have the largest stakes, that own the most Ethereum, they have a higher probability of being asked to verify these transactions within a block. Okay, and it's much more energy efficient. But it's not just proof of stake and proof of work. There are dozens of other mechanisms, and they're very interesting. We will definitely go through them. There's another class of blockchains that are called private blockchains, and here trust is required. Indeed, some people don't like calling them blockchains, so we'll call them distributed ledgers. But to me, it's effectively the same thing. So think of this as a hybrid. We're using some of the benefits of blockchain technology, but you actually have to trust the people that are verifying these blocks. So think of an example. Suppose the Federal Reserve decided to issue US dollars on a blockchain. Well, that would be permissioned, and the people that would be approving the additions to the distributed ledger would be, for example, the 12 regional Federal Reserve banks. So you'd have a mix of trust within this particular blockchain technology. So what I want to do now is to actually explore a particular blockchain. And we will talk about many, but at the beginning, in the overview part of the course, I want to go and take a fairly broad view of the Bitcoin blockchain. We're going to go into some applications immediately of this idea, but let me give you the big picture. The first thing is that this ingenious type of database is going to be very useful in terms of verifying ownership of whatever. So it could be a good, could be a service, it could be basically anything. This is a record. It is a record that cannot be altered. So it's not like a hacker can go in and alter the ownership of a particular asset. It's not like the government can go in and alter the ownership of a particular asset. It is set in stone. And the second use is the efficient exchange of ownership. So we can do a transaction within this blockchain construct that effectively signs the ownership from one person or entity to another person or entity. It is immediate, it is secure, it sets the historical record. It is done without a middle person. You're interacting. The middle person is the computer program and the database. This is fundamentally peer-to-peer. And it's peer-to-peer in a very special way. Everybody is treated the same. There's no distinction between a customer, a retailer, or a banker. Everybody is a peer. This is transparent, immediate, secure, and it opens up the door for many applications. And next, we'll go through some low-hanging fruit in terms of applications. Okay, so blockchain is this very special database that's got these very interesting features. It's distributed, which means identical copies of the database reside on many computers. And those computers are called nodes. There is a degree of transparency that is a choice, and we will talk about different choices. And there's also a couple of other features that are crucial. One is this idea of immutability, that this is a record that is set in stone. And the fourth idea is this very interesting way that the database is constructed. It's constructed in blocks, and these blocks are connected. One block's last line is the first line of the next block. So what about some immediate applications? I want you to be thinking about applications immediately. The best way to do this course is to understand the technical material, but immediately relate it to what a potential application is. So let me put a few teasers out in terms of applications. So this is a photograph of the New York Stock Exchange in the 1920s. And to settle a stock transaction in the 1920s took 5 days. Okay, it's kind of understandable. No computers, very crude sort of situation. In the mid-1990s, there was what was described in the media as a revolution, where we moved from 5 days to settle a stock to 3 days, which to me didn't seem like much of a revolution, given this is the beginning of the internet. We should be able to do better than 3 days. Last year, there was another significant advance where it's now 2 days. And that, to me, doesn't make any sense. So with blockchain technology, there is the possibility of having a database of a particular stock's issuance, and the settlement, the transferring of ownership of the stock can happen immediately. All major stock exchanges in the world are investigating this technology. Indeed, the Australian Stock Exchange, which is the 10th largest in the world, is committed to moving to blockchain technology. So this is an example of low-hanging fruit. Well, I'm not sure about you, but if you've ever tried to buy property or a house or an apartment, it is a nightmare. Indeed, the procedure is not that much different today than it was 50 years ago. So if I'm buying, let's say, a house, one of the risks is that I pay somebody for the house that's supposedly the owner, but maybe they don't own the house. So in order to be secure, I need to employ lawyers to figure out who actually has the title. If I want to get a mortgage, it's kind of the same thing. The bank doesn't want to loan me any money to pay to somebody that might not own the house. So as part of the mortgage process, I need to get title insurance. So this protects the bank if something happens that the person I'm paying for the house doesn't actually own it. So again, blockchain technology, this is low-hanging fruit. There is a ledger. And sometimes blockchain is called distributed ledger technology. There's a ledger that's available municipality by municipality that lists all of the property, the houses, the apartments, all of the liens on these properties. And we look up who owns the house. It's clear, it's immutable, and we do a transaction. You don't need a lawyer to do a title search, you do not need title insurance. This is a low-hanging application of blockchain technology. Another big picture issue is the messaging system that we use today to transfer money. It's called SWIFT, and it is constantly under attack by hackers. These transfers are not secure, and people understand that it's just a matter of time where SWIFT will be so insecure that it just will not be useful. So the idea with a blockchain technology, you can do these transfers securely, quickly, inexpensively. So this is another obvious application in terms of money transfer. Well, what about counterfeiting? It's actually a real art today, and a number of countries, a substantial amount of their revenue is from counterfeiting. So blockchain effectively takes the serial number in a currency seriously. So with a blockchain-based cryptocurrency, you cannot easily duplicate. Okay, another obvious application is verification of ownership. So think of the following scenario. You get into your car, you scan your face, a blockchain database is checked, and you're the owner of the car. The car starts. And indeed, it would start for anybody that you permission to drive your car. Now let's change the situation slightly. Suppose you buy the car, but you get a loan from the bank. And in the loan contract, it says that you're in default if you miss 3 monthly payments in a row. You get into the car. You've missed 3 monthly payments in a row. You do the scan. The blockchain construct is checked, and it notices that you are in default. The car does not start for you. It starts for the bank. This is an example of a smart contract. So essentially, you're using a blockchain-based construct where there's a small computer program running that says, go check the bank's database to make sure this person or entity is not in default. The answer is obtained, and then the contract is executed. So we'll talk more about smart contracts, but it gives you an idea of the power of this technology. So this is a technology that is peer-to-peer, and its greatest application is where there is a thick layer of middle people. Indeed, when you're thinking of the possible disruption possibilities of blockchain technology, the first stop is to look at particular industries that are characterized by a lot of middle people. So financial institutions, as I've already mentioned, are a prime target. They're middle people. So we will talk throughout the course about many applications of this technology, but I wanted to give you a taste of what's to come. So this course has got technical aspects to it, and we'll go through some of the mechanics of blockchain, but I really want to emphasize the practical applications. So let me go through some of the applications. We'll do many more in the course, but I just want to give you a sense of what's possible here. So one low-hanging fruit is voting. There's always stories about voter fraud and ballots being lost. You're asking for trouble with paper ballots. So if you've got a system that's secure, like a blockchain construct, then if you are a citizen, you get a token that gives you the right to vote. The token can be used once. It cannot be sold. It expires after the election. The results are instantaneous, in real time. The voter, of course, to actually spend this token to vote, needs to prove that they're the owner of the token. And again, very straightforward, thumbprint, facial scan, can allow the voter to provide identity. So this is something that solves a lot of problems. Of course, in the short term, we'll have to deal with paper ballots alongside blockchain ballots, but I think that this is where we go. People can vote on their smartphone. It will increase participation for sure, and it will definitely reduce the disputes that are commonplace in elections around the world. The Internet of Things is also a growth area for blockchain applications. A picture of my Nest. Many of these devices are just wide open for hackers. Hacker comes in, takes over your device. You have no idea what's happening. They're using your internet connection to spam people. They might even do something nefarious, like turn up the temperature and make it very uncomfortable for me, like take over my device. So again, blockchain allows a technology whereby I'm the only one, or people that I permission, to deal with changing the temperature on my device. So it might be uncomfortable for me to deal with an extra warm or cold temperature in my apartment, but there are other Internet of Things applications like self-driving cars that we cannot allow to be hacked. So I'm in a self-driving car on the highway, some hacker comes in and takes it over. You know, there's just no way that we can allow that. So I believe that self-driving cars are actually a non-starter if they're not integrated with blockchain technology. I want to be the one that has the last controls on the car, not some hacker. So another application that's low-hanging fruit are prescription drugs. And it is a massive problem in the US right now with opioids. It's an epidemic. And the number of people dying is staggering. And the system is a legacy system where somebody can go into the doctor's office, steal their script, and write 100 prescriptions for opioids, go out, collect at various pharmacies, each one of them, and then sell them to people that shouldn't be actually consuming. So think of a different model. You go into the doctor's office, there's no paper. You're issued a token. And that allows you to go to any pharmacy and redeem that token for the right to buy the drugs, which hopefully are needed by the patient. So that token, again, cannot be resold to anybody else. You need to prove your identity, just like voting, in order to actually spend the token and get the drugs that you actually need. In addition, all the doctors that are prescribing are in this blockchain record, and the patients that are receiving are in this record, and the regulators can see if something is adrift. Medical records or any type of private records is another low-hanging application of this technology. So it's often the case, and this is sad, that you might have a major hospital with millions of patient records, and those records are protected by a single password. So if somebody gets that password, they've got access to all of the records, and that can cause a lot of problems for the patients. So think of a blockchain construct. Think of it as you've got your own key for your own medical record. So it is true that a hacker might be able to get that key. But in going into the database of the hospital, maybe they could hack 1 or 2 records, but it's unlikely that they can get in and discover millions of private keys. It provides much stronger protection. It also allows you to easily transfer your medical records. Financial statements. So why are they quarterly or annual statements? It is basically a legacy system that people decided upon quarterly or semi-annual or annual. This technology allows for real-time reporting. The same material that you see in a financial statement can be made in real time available to investors. So again, it's the same material, the same sort of metrics that we see in the financial statements for the public. And within the firm, you can have much more detailed real-time data using blockchain technology. Another very interesting example is a so-called digital twin, where I give the example of a jet engine. Jet engine is very difficult to resell in the secondary market because people don't know what's happened to the engine. We don't know the service, we don't know a lot of the details of the usage. So think of a technology where every single part that went into that jet engine is put into a blockchain construct. Every single electronic sensor reading, every repair, every new part is put into a blockchain. And then the buyer can look at that and see exactly what's happened in terms of history. And it makes it much more easy to transact. This is an extreme example of a jet engine, but you can think of more practical applications such as a car. What about FedCoin? So, and this is striking, that 79% of the value of US currency is in $100 bills. So I don't have a $100 bill on me, and I doubt that you've got a $100 bill on you. So how is it possible 79% is used in $100 bills? So essentially, the point is criminal activity. And here's an example, El Chapo, that's a stash in Mexico. And if you look carefully, those are $100 bills, a huge number of $100 bills. So essentially, cash currency is the choice for criminals. So if you go to a blockchain-based currency, then the history of the transactions are available to the regulator. And I think there's many advantages. And we'll go into more detail about this, but for example, there's no cash payments under the table to essentially avoid taxes. There's also the possibility of instant monetary policy. A line of code could provide a helicopter drop of funds. So let me stop there on the applications, but this final graphic is quite interesting to me because it's a report put out by the UK on blockchain technology. And it talks about some of the things that we've already talked about, but it also is a teaser for some other ideas. So, for example, in the middle, do you see that passport? Like paper currency, passports will be based on blockchain technology. So again, you scan, check the blockchain, this is a citizen of this country, and you pass through customs. See the diamond up there? Why is a diamond in a blockchain? Well, in the diamond business, there's a real problem with so-called blood diamonds. So the way to prevent that is to put a code, laser code, into the center of the diamond that you can't see, and then the clean diamonds go into a blockchain construct. You receive the diamond, you check the blockchain, you know that it's clean. There are many other applications that we will talk about in this course. This is just a sample of where this space can be very disruptive in terms of business that exists today and the potential creation of new businesses. So the last part of the overview of this course has to do with what I call the tech big picture. There's certain technical aspects of this blockchain idea that we need to understand. And I'm going to list these technical ideas and think of them as a checklist. Throughout the course, we're going to learn about each of these items and we'll check them off. And by the end, we'll have a very good understanding of blockchain technology, how it works, and what its potential actually is. There's also many risks and unanswered questions. So I will also deal with those questions later. So number one tech issue we've already talked about a bit, and that is hashing. So hashing is an integral part of blockchain technology. We saw that a hash is a digest of the information or a fingerprint. It summarizes all the information in a block. It falls at the end of a block. And if there's any change, any even subtle change in a block, then the hash signature will change. It is a one-way function. It's not meant to be undone. And in Bitcoin, we use the SHA-256, which is 256 bits, zeros and ones. Ethereum uses a different type of hashing algorithm. The hashing algorithm is a choice of the blockchain technology. We will go into some depth as to how this works. It is important for understanding this particular technology. Number two has to do with private keys and public keys. So as we'll see, your private key is something that should not be shared with anyone. It's yours, and it gives you the right to spend or to transact. So the idea of having a key is as simple as a random number. So the private key, think of it as a random number, a long random number. And this key is mathematically linked to a public key. So we'll go through some of the technology that allows us to do this. The public key can be shared with anybody, but this is important. With the private key, we can, with mathematical operations, figure out what the public key is that's associated with the private key. However, it's incredibly difficult to go the other way. So if you've got the public key, to figure out what the private key is very, very difficult. Okay, so this means we can freely show our public key, and it doesn't reveal anything about our private key. The private key is crucial for actually spending or transacting. The third is the so-called public address. So this is very much related to the public key. So we need to have some sort of address to receive. If somebody wants to send me something, they need to know where to send it. So I'll have an address that's publicly available. And in Ethereum, it's as simple as the public key. So that is your address. In Bitcoin, it is a function of the public key. And it could be as simple as a representation by a QR code. So the next part is digital signatures. So an algorithm is used, a so-called digital signature algorithm, or DSA, where you sign over a transaction. Okay, so this digital signature proves, along with your public key, that you're actually the owner of the private key. And again, we'll go through much more detail as to how this actually works. But this is crucial technology that is standard in blockchain implementations. And the digital signature algorithm that we'll talk about is the so-called elliptic curve digital signature algorithm. The next thing has to do with the actual mechanics. Like, how do these transactions actually work in a blockchain? So that will depend upon the particular blockchain. For example, in the Bitcoin blockchain, suppose that I've got 10 units and I want to send 7 to Jenna. So Jenna, she generates a private key, which is a random number, and then mathematically figures out what the public key is that's associated with that private key. So she's got an address, and I will do a transaction where I send 7 to Jenna out of this original transaction where I've got 10, and then I'll send 3 back to myself. So think of this as change. So this is one way that a blockchain actually works. Ethereum has a different system. So we'll go through these mechanics to make sure that you understand how they actually work. The other part is cryptography. And this is the subject, obviously, of a whole course. But it's important for you to understand the basics. So it turns out that cryptography is used in blockchain technology via digital signature algorithms, but there's not necessarily any encryption in a blockchain. Again, it's possible to put encrypted data into a blockchain, but the actual mechanics of a blockchain doesn't really rely upon encryption. Nevertheless, this is very important. The technology that's used is important, for example, in deriving the public key from the randomly generated private key. So we'll spend some time doing some simple ciphers so that you understand the basics of cryptology. The second last thing is consensus mechanism. So there needs to be some sort of consensus as to what the truth is in a blockchain. So it turns out that there's many different ways to do this. Bitcoin has got a particular technology called proof of work, where miners are verifying transactions and solving a very difficult problem that takes a huge amount of computing time and computing resources and energy. Other technologies might have something like proof of stake, where there's a voting that goes on, and the size of your vote depends upon how much of the coin that you actually own. And the more coin you own, the more vote you have, but it's also the case the more coin that you own, you've got a vested interest in doing the right thing. So this is a different type of mechanism. It's much less energy intensive. Ethereum currently is proof of work, but they have a schedule to move to a different technology, the proof of stake. These are only two consensus mechanisms. There are many more. We will go into some detail in proof of work and proof of stake and talk about some of the other mechanisms also. Finally, we need to talk about incentives. So in a proof of work system, miners are rewarded in terms of the work that they do. They verify transactions, and they do this difficult computational task that allows them to win some newly created coin. So they are directly incented by this reward. They're also incented in a different way in that they collect small transaction fees. So rewards are important. In the Bitcoin system, eventually the reward for mining will go away, but it will be replaced by the transaction reward. So this idea of incentives is important for people to act in a way to preserve the integrity of the system. There need to be incentives. So within the tech big picture, there's certain things that we're going to learn about and understand in terms of the progress that's already been made, but there's other key questions that have not been resolved. So I want to stake those out very clearly. And work is ongoing. So a good example is latency. So Visa does about 24,000 transactions per second. Now, if you look at Bitcoin, it's a handful of transactions per second. Ethereum's a bit better, Litecoin a little bit better, but it is nowhere close to Visa, and Visa is only one network. So how can we grow that? So how can these blockchain technologies become not just competitive to Visa, but to go well beyond what Visa is doing? In the vision of the blockchain world that I have, what's necessary isn't 24,000 transactions per second, but potentially billions of transactions per second. So we will talk about some of the ideas that have been proposed in terms of level 2, potentially level 3 sort of technologies. This has not been resolved. It's an open question. Number 2 has to do with data. And the basic idea is right now, the current blockchain technology, it's not really feasible to keep a copy of giant databases within a blockchain. So right now we have blockchain-enabled distributed databases that are outside a blockchain. But I think that this is probably a temporary problem. And as you can see, the cost of storage is exponentially decreasing. So in the future, this will probably be resolved where there won't be a database associated with the blockchain that has large data. Everything will be in the blockchain construct. Another issue has to do with the connection of the chains. So if we're headed to a world of millions, if not billions, of blockchains, will there be some way to connect them so that we can do very simply transactions from one chain to another? And we'll talk somewhat in the course about side chains and other technologies that actually allow this. Privacy. Privacy is a big issue. And what I want to emphasize is that it's not just a blockchain issue. So currently, it's very easy to do messaging or telephone calls in a completely encrypted network. And there's some issues with that. It allows criminals to communicate with each other and potentially even terrorists communicating with each other using these networks, and there's no way to monitor what they're doing. The same issues arise with some of the blockchain technologies. And I say some because the key ones today are open and transparent. But there are some technologies like Zcash that are anonymous, and we have to deal with these privacy issues, and it is a topic of ongoing discussion. There's also a big issue in terms of the verification of data that comes from outside the blockchain. So the technology to go outside of a blockchain to, let's say, the internet in general, to a website, is called an oracle. And much work needs to be done on this technology to make sure it's secure. Essentially, what you don't want happening is the data coming from outside the blockchain to be corrupted. So these oracles, again, are ongoing work. It's a big problem. It will be solved, but it's not solved right now. And oracles are integral to the next kind of generation of blockchains that use smart contracts. So immutability, I argued that blockchain, the way it's constructed, allows us to set things in stone, that history cannot be changed. But there's also an issue of forking. So where a change in the technology of one particular protocol, for example, Bitcoin, is adopted by some of the users, and a new technology is created. For example, Bitcoin Cash, Bitcoin Gold. These are forks that use the history of the Bitcoin blockchain, but then go off in a different direction. So that needs to be discussed. This is a problem and an opportunity. So it's important that we understand it. Governance. So many of these public blockchains, you can challenge their viability in the future because of governance. So we are faced with a technology with decentralized governance. And it's naive to think that the code that drives these blockchains will never change. It's certainly not the case. The original code that was written by Satoshi Nakamoto, that code was code that's been improved many times. And some consensus is generated on the network to accept these changes, many of them non-controversial. But if there is a substantial change, then it is very difficult to get consensus. So I will talk about the different models of governance in the course and the different approaches across different blockchains. Use case is very important. Unfortunately, today, given all the hype of blockchain, many companies are adopting a technology, which is blockchain technology, that might not be necessary for the actual application. So this is the basic situation where the technology needs to match the application. So maybe it's not a blockchain, or maybe it is a blockchain that you need, but a particular type of blockchain. So is it a public blockchain that you need no permission to write to, or is it a permission blockchain? So the use case is very important. Right now, there's a swirl of misunderstanding and misadoption. So this is very important for the course to understand what technology is necessary. Regulation. So this is a deep problem. Essentially, we're faced with the following, that this is a technological disruption that has not been anticipated. So the current laws don't really allow for this technology. So new laws have to be written. And there's a steep learning curve for the regulators. This is complicated. And once they learn about the technology, we need to design efficient regulations. Indeed, you need to be very careful, because as soon as there's over-regulation or excessive regulation, then startups will just go offshore. They will arbitrage the regulation and go somewhere else. So this is very important. And finally, there's the open question, given that we're headed towards the world where AI, machine learning, deep learning, is much more prevalent, a part of everyday life. Is there a nexus between artificial intelligence and blockchain? And there are a number of companies working exactly in this space. Have they figured it out? No. But I think that this is a very exciting path to pursue, as we will in this course. So this is the overview of the course. You can see where we're going. I'm excited to take you on this journey. So what are the takeaways? The first thing is that this technology is complicated. There's a lot of misunderstanding. So we need to understand certain key items unambiguously. The first thing is that there's no one blockchain. People talk about the blockchain. As soon as they do that, it indicates to me that they don't really understand that this is a technology. There's many different ways to implement this technology. So given that there's a diversity of different implementations, it's important to realize that you can tune an application of blockchain to match the needs of a particular business situation. And that's part of the skill here. So you might say, well, this business could benefit from using blockchain. Well, that's just not good enough for me. I want to know more detail in terms of the technological implementation of the blockchain. So is it a public blockchain? Is it a private blockchain? What is the consensus method? And indeed, there's a lot of confusion. People say, well, we can't use blockchain because it's too energy intensive. And that to me indicates they don't understand what's going on. Yes, Bitcoin is very energy intensive, but that's only one application. There's many other blockchain applications that don't require energy-intensive mining. Okay, so the other thing here is that blockchain is so linked to cryptocurrencies. I will make it clear in the course that cryptocurrencies are but one application. And indeed, today that application we saw was very diverse. There are many different ways, different models of cryptocurrencies. But there are many blockchain applications where you don't need a cryptocurrency. So to me, in looking at this technology, I see these fundamental implications. So one, we worry a huge amount about security. It seems every week there's a major hack. I've reset my credit cards, I don't know how many times in the last year. So this provides a solution where information is codified, it's set in stone, nobody can alter it, whether it's a hacker or a government. It is a record of history with unprecedented security. And the second big idea that I will push throughout the course is this idea of the end of transactions costs. There will always be very small transactions costs, but really small. What we pay today is ridiculous. A 3% swipe fee for a credit card? That is just essentially paying for middle people and paying for the lack of security, because the credit card company has to make whole somebody whose card gets stolen. So if you don't need to deal with that security, then you don't need the 3% fee. So instead of 3%, maybe it's 0.0003%. So this has dramatic implications in terms of what we can actually do. That microtransactions are now possible. Exchange of ownership is quick, efficient, and secure. New types of assets can arise. So this technology has fundamental applications in terms of how we actually transact. And in closing, let me emphasize the benefit of this technology for inclusion. The 2.2 billion people in the world that are unbanked, that don't have a debit card, they don't have a credit card, they're stuck. With this technology, we open up the modern world to them. And I think that that's a big idea. And we should be thinking about what the implications for growth are. New businesses all of a sudden arise. Somebody in an emerging market can monetize a product like they could never dream of before. So I think that we're in for an era of much higher than expected growth, driven by bringing in this wave of human capital that has been prevented by constraints from accessing the modern world of finance, whether it's a small loan for a business or selling a product on the internet. All of a sudden, those constraints are broken. We bring them in. This surge in human capital will lead to growth that's unexpected. That is great for emerging markets, but anything that's good for these markets is also good for developing markets. So these are big ideas. My course deals with many concepts that go beyond the technology, that talk about the actual economic implications for our society, our world, as a result of blockchain innovation.